Right, I assume you can all see my screen. What we're going to do is we will be running this in two parts, as Steve said. Tomorrow is not a repeat of today. Tomorrow is the second half of this training presentation. So make sure that you tune in tomorrow for part 2. This training course, the purpose of this course is to give you a better understanding of how printing works. Designed to get the best out of your printer and your media, and it will show you how to overcome some common problems. What this course is not, this is not a detailed training course for a particular printer type. We've got the better part of getting upwards to 100 people on this training course that are listening in. There will be multiple different types of printer platforms, so I can't be too specific about one type over another or one particular printer over another. This is going to be specifically general to different printers, and you'll see what I mean as I go through. We'll talk about the main printer types. What we will be talking about, we will talk about the print process, the printer environment, how you handle your media and store it. Then we'll talk about the printer and its operation. Then later on tomorrow, we'll get on to color management and troubleshooting. Where we stop today, we'll stop around sort of an hour and 20 or so to give us a bit of time for some questions. I'm not 100% sure which slide I'm going to end on, but we'll work it out as we get there. Okay, so carrying on with the detail. Digital printing technologies. Just before I kick off with this course I have been running for a while, so I know there are some people on the call that have possibly seen this before. I recently had the sense checked by some digital printing experts, so what I'm saying is the latest information. There are some slides that have been changed and updated, and some of the things I'll say will be new information, because none of this stays still. Things change, particularly in the digital world. Okay, looking back at the printing technologies and where we've come from. The original printing technologies that 3M were involved in were the electrostatic printers. An electrostatic printer, the best example of that would be a photocopier. A photocopier is an electrostatic printer. It uses an electrostatic charge to pick up toner particles and fuses it onto paper. 3M had a printer like that called the Scotch Print 2000. That printer, we released it in the late 90s and we only stopped supporting it about 5 or 6 years ago. That's one hell of a long run for a printer. Most printers these days will get a life of a couple of years, maybe 5 years at the absolute most before they stop supported. This printer we supported for over 20 years purely because we had to. That was the only printer that was able to be used to print aircraft marking graphics. So we supported that printer for a lot longer than it really should have been. And that was basically an electrostatic printer. So it took toner inks or toner particles and took them via a carrier medium and then fused them onto the vinyl. So quite a complex process, but it worked remarkably well. The beauty with the electrostatic printer is it produced an incredibly durable graphic. So the graphics that were produced on there could survive on aircraft, and they lasted years and years and years. The detail wasn't very high, so the dots per inch were fairly low, but they did a really good job for aircraft marking. The next type of printer you see across there, thermal transfer printers. Thermal transfer printers, the best example of those that most people would know today. If you go into a New Zealand Post shop to get a new license label for your car, that whir that they do and then that rip of the label, that's coming out of a thermal transfer printer. So that little label that you've got in your car is produced by thermal transfer printing. The way that works is that takes a wax or a resin ribbon and it melts it onto the surface of the label with a head that can heat up very small spots and transfer that material onto the label. There are actually wide format versions of that. I've never seen any in New Zealand. There may have been some, but I've never seen any. There was a company called Matan based in Israel that produced one. So they produced a 1220 wide printer. It was a thermal transfer printer. There are narrow versions of thermal transfer printers around, and the best example of those is the Gerber Edge. And I know there are a few of those around. There are still a few companies with Gerber Edges, and they do a really good job, but they're only about 360 millimeters wide. So we're talking narrow format, but they are essentially a thermal transfer printer in the same way. Now, the beauty of thermal transfer, and it did have some really good uses. You could get custom colors quite easily. It was just a matter of transferring one ribbon for another. You could get metallics, you could get custom colors, you could get all sorts of unusual things with a thermal transfer printer. But the problem was it was only narrow web width, so it was only 360 millimeters wide. That brings us on to the inkjets, piezo and thermal inkjets. The original inkjets were thermal, so they basically used an aqueous liquid and they used a hot head to fuse that liquid onto the surface. The beauty of those is they were fairly quick, they were down and dirty and cheap, but the trouble was that they didn't last very long. The original thermal aqueous printer would produce great graphics for shops where they've got a sale today or sale this week, stuff that you hang in the windows that is only going to be up a short amount of time. And the reason for that is they faded, and they faded really quickly. There was not much instability in those inks, so those thermal inks didn't last very long. That brings me on to piezo inkjet printing. You've got a range of them there. That's circled with a big red circle for a reason. That's pretty much where all the printers that you've got today in your shops, they will be one of those types. The original was the solvent printer, and a good example of that would have been the Mamaki running the old HS series ink. Horrible, stinky ink. No one wanted to be in the same room when that printer was working, but it produced a really durable print. Then they decided that, well, from the solvent prints really smelled bad, they produced eco-solvents, and that's a number of the Rollins that are around, and Mamaki's running the SS21 ink. They all use an eco-solvent ink. They're much, much more friendly inks, so the ink is much more mild, so it doesn't smell nearly as bad. Still takes a while to dry, and we'll talk more about drying later, but it was a much better solution. It was much more friendly. There weren't as many harsh solvents in that ink. Then came the UV curables. That was an ink that used a UV stabilizer, and you ran it through a very bright UV lamp, and that cured the ink. Everyone thought about 10 years ago that was going to be the way that it all went. Hey, wow, UV, isn't it the best thing since sliced bread? Because they could produce an ink and a printer that meant your print was dry straight off the printer. If you cured it correctly, then that print was absolutely fantastic. You could use it straight away. You didn't have to wait for it to dry. Until people discovered that UV ink, when it's cured, tends to become very hard. And that caused a few problems if you wanted to wrap something. So it meant vehicle wrapping wasn't possible with the UV cured ink, because the ink being hard would crack if you tried to stretch it. That has been solved to a certain extent, and a number of you will have Mamaki UCJV 300. That's a UV ink that is relatively soft and will wrap, so you can wrap a vehicle with that UV ink. So it is one of the new generation of UVs. In the meantime, HP came up with using latex, and they decided that a latex printer would be the way to go. And there are now a number of other companies that are also producing latex printers. They are essentially an aqueous printer. So what they do, they could also be classed as an aqueous thermal printer, but there are differences in the way that the ink is laid down. So the aqueous piezo is genuinely the latex printer. Now what that does is that uses an ink with latex, which is flexible, and they suspend that in a lot of water, and then they dry a lot of that off. So essentially the latex is an aqueous piezo printer. So those essentially are the 4 types of printers that you'll have in your shop. Solvent printers, going very much the way of the Dodo. Eco-solvent printers are the older school ones, but they're still very popular. A lot of people are running UV inks, and the vast majority of modern printers are latex. I often get asked, what printer do you recommend? I don't actually have a particular preference. Really all I can say, because if I do get asked, and if I said HP, then Mamaki will get upset with me. Or if I said Mamaki, Roland will get upset with me. So really all I can say is the market tends to be moving towards latex printers. It doesn't matter whose latex printers they are, but we're seeing a big push towards latex. And just lately, we've seen a big push into the Mamaki UV inks as well. So we are seeing a move away from solvents and eco-solvents. Piezo printers. The big question now really with piezo printers is, well, how do they work? A piezo crystal is a crystal that changes shape when you actually apply electricity to it. So what you see from that rather poor looking diagram, it's the best I had. If you supply a charge across that crystal, it will change the shape of the crystal, and it pulls up on the membrane, and it will suck a little bit of ink out of the reservoir. You can see here on the left diagram, it pulls ink out of the reservoir into the nozzle chamber. Then when you reverse the polarity, it changes the direction of the shape of the crystal, and it pushes down on the membrane, and it pushes out a drop of ink. When they then turn off that charge, that ink drop gets released. That ink drop is incredibly small. They're measuring it in picoliters, and that's one with all of those zeros behind it, one over that, and that's very, very small, a picoliter, very, very small droplet. As time goes on, and the latest thinking is that we are still in picoliters, but even the picoliter size we're getting out of the nozzles is getting even smaller. The smaller size of ink drop basically means you can get a more detailed or a higher resolution on the ink. So, on the print. So you will end up with a better looking ink drop, or a better looking print. The trouble with that though is if you go down in ink drop size, you need more ink drops to create the image. So it tends to slow the printers down. So you either need to run the printer faster, or you are going to get a slightly longer delay time because it's going to take longer to put that much ink down. Or you end up with more heads. Some manufacturers are putting more heads in there. Lots of different ways of doing it. Brings me on to print heads and airflow. The ink drops are easily blown off course by air currents. So what we're essentially saying there is, if your printer has certain covers and air ducts and fans, don't remove those, don't turn off the fans, don't add extra fans, because the ink drops will get blown off course. I don't know how much of this image you can see, but where the 9 is, it's a nice looking image, but further over, the image gets a bit ratty. That was actually created by my colleague Chris in Australia. Chris actually blew under the head while it was printing, and it essentially blew the air, blowing air through, blew the ink droplets off course. So essentially what he was demonstrating was some people thinking, oh, they can get their ink to dry more easily by adding another fan in there or blowing some air through to try and dry that more. No, essentially all he did was ruin the quality of his print. Your printer has been set up specifically to hold the ink in a certain configuration until it gets onto the surface. So don't muck around with the air currents, don't muck around with the fans, leave the covers in place. It will essentially create a better looking image. The next one is dot gain. Dot gain is about what happens when that ink drop actually touches the surface. The ink drop will spread out when they land on the media. So what happens is, if you're printing on paper, you'll get a much bigger dot gain, and you'll get something that looks like the bottom of that. You'll get a very, very diffuse picture. The dot will hit the surface and it will soak into the paper and spread out. Now, if you put that onto vinyl, it's not going to spread out nearly as much. So different types of media will have different looks. And that brings me on to something that I'm going to talk about much later. It'll probably be in tomorrow's presentation, and that's printing proofs. So if you print a proof on paper, it's not going to look nearly the same as if you print that proof on vinyl. So if you're printing proofs for the customer, print it on the same media that your customer is actually going to be looking at. So don't print it on paper if you're printing it on vinyl, because it won't look the same. So essentially what we're saying there is different surfaces will absorb the ink in different ways, and it will have a big effect on the outcome. So don't expect it to look the same if you print on different media. Brings me on to ink chemistry. Quite different chemistry in the inks for solvent, UV, and latex. Solvent inks cure by solvent evaporation after printing. So essentially what we're saying is, when you put a drop of ink down on the surface, that solvent needs to be evaporated off to allow the pigments to remain keyed into the surface. Solvent prints The way solvent prints work generally is the solvent is harsh enough to bite the vinyl. So essentially what happens is it lands on the surface and the solvent ink will get pulled down into the surface by, so the pigment will get pulled into the surface by the solvent. The solvent will dissolve the surface slightly and the pigments will get down into the surface. So when the ink evaporates, so when the solvent evaporates out, the pigments from the ink remain there and they actually remain keyed into the surface. They will get right down into the surface. So for those of you with solvent printers, and there will be a fair number of you out there with solvent printers, you get an ink drop in the wrong place and immediately it comes out, you want to try and clean that drop off, and you take a bit of solvent and you try and wipe it off, you'll often end up with a dirty brown mark left behind. That's because that pigment has already keyed down into the surface. And the solvent has already bitten into the vinyl. So the solvents will key into the media, allowing the pigments to pull right down into the surface. Now UV cured inks, exposure by UV light will cure them. So there is a chemical in there that reacts with the UV light and hardens. So what it's doing is it hardens, and it hardens with the pigment inside it. It's cured on the printer and it tends to be cured on the media surface. So a UV ink will tend to be sitting on the surface rather than in the surface. Now that was the issue that we had with the solvent, with the vinyls that we were using for vehicle wrapping. When you tried to stretch them around the surface, the inks being quite hard and sitting on the surface would crack. And you could actually, in some cases, get the inks flaking off. While it was a great print if it was kept flat, it wasn't necessarily such a good look if you tried to conform it to the surface. And that was because the inks were hard because of the UV curing, and they didn't cure into the surface, they cured on the surface. Now I'm going to get a little bit funny here. For you guys with UV printers, you've got a choice of a couple of different curing methods. You've got a choice of curing on the leading lamp and curing on the trailing lamp. Those of you with UV printers should understand what I'm talking about. What we find is that for a nice, smoother surface, we tend to turn on the leading lamp. So it sounds counterintuitive that you turn on the lamp that's actually in front of the head. But essentially what it's doing is it's curing the previous pass. So you lay down a layer of ink, and then as the head goes back the other way, the lamp which is turned on in front of the ink heads cures that previous pass. That's called leading lamp cure. The reason we use leading lamp cure is that it allows the UV ink a little bit of time to settle down a bit onto the surface. So it tends to flatten the ink down a bit. So you get a slightly smoother surface if you leading lamp cure. Trailing lamp cure turns on the lamps directly after the print head. So as soon as the ink is laid down, it's cured by the lamp coming in behind. So different curing regimes will give you different looks. A leading lamp cure will give you a smoother look. A trailing lamp cure will give you a slightly rougher print. We use UV printers for creating road signs. Like road signs are generally printed with UV inks, and we always cure them with a leading lamp because we want the ink to wet out a bit more onto the surface. That's why we use a leading lamp cure on those. Now the last one, they're latex inks. Latex inks cure by evaporation of water and co-solvents. Now, what does he mean by co-solvents? I can hear you thinking. Now, essentially, latex ink, a lot of people will think, oh, it's just water and ink. No, it's actually a mixture of water and solvent and pigment. To be a latex ink, the general thinking is that it has to be at least 70% water. That means you've probably got 1 or 2% pigment, which leaves you 28 or 29% co-solvents. Those co-solvents are evaporated off while the inks are curing. So curing of those inks essentially happens by drying off the water, and because you've got to put so much energy to dry the water off, you will also drive those co-solvents off at the same time. The latex inks tend to run very hot. A latex printer, I would expect to be running somewhere between 80 and 120 degrees. How hot it is depends on your printer, the make, the model, what you're printing, how much ink you've laid down, but that essentially it's running much hotter than a solvent printer, which will probably be running 40 degrees or so, 40, 45 degrees. UV curable inks, you don't actually run them at a temperature, you just run them with the UV lamps, which are hot anyway. Latex inks are cured on the printer, so if you do it correctly and you dry off all those water and co-solvents, you will end up with the ink cured straight off the printer. So solvent inks need to be dried, UV cured, and latex inks should both be cured off the printer. Brings me on to media storage and handling. What we're going to have here is, essentially what I'm saying is, when you get boxes delivered to you, try and keep them flat. Don't store them up on their ends like that, that picture in the bottom there with the media stored on its edge. Don't store it vertical, try and store it horizontal. What tends to happen is if you store media vertical, the adhesive in there is actually a liquid. It is a thick liquid, but it is a liquid and it will tend to flow. So the longer you leave a roll standing on its edge, the more it's going to try and push its way through to the edge of the roll. So you're going to end up with a slightly sticky edge. Usually it's not an issue, but it can be. So what you've got there is rolls that have been standing on the edge for a long amount of time. As you try and unroll them, you can get slightly sticky edge on them. So that's why we try and say keep them horizontal. Correct temperature, clean, dry, dust-free, and out of direct sunlight. Really what I mean by that is that what we recommend is keep the media with the printer wherever possible. Don't store it in really cold environments or really hot environments. Try and store it in the same environment that you'll be keeping your printer running. So really
Sorry,
what we
Michael,
yep.
can I just jump in with a question? We've just got one from Stuart. With the UV lamps, is it useful to have a leading lamp a lower temp than the trailing lamp if you're running both lamps? Or should you just run one lamp at a time?
Generally, you'll find that one lamp at a time is what's done, but it's going to depend more on what you do. You'll find that if you've got a particularly difficult media that you're finding hard to cure, you can turn on both lamps. Some printers will have the ability to alter the power rather than the temperature, alter the power on the lamps. And yeah, I would generally say I would lower the power on the trailing lamp to give it a little bit more time and then finish off the cure with the leading lamp. But that's going to be very, very dependent on what you're printing. If I was printing a banner with great big thick layers of ink, then I probably would turn on both and turn them on full bore because you're going to need all that power to cure it. It really depends on how much ink you're laying down as well. Good question, thanks.
Cool, thanks, Mike.
Okay, keeping things in the correct environment. Clean, dry, dust-free, out of direct sunlight. All of that's not rocket science, guys. Just try and keep it in the best environment that you've got. When in use, horizontal storage is still the best. Avoid damaging the film on vertical racks. And we say dispose of the first ½ meter of film when loading to avoid contamination. I've got a couple of lovely stories that go with this. Firstly, with storage. Many, many years ago, probably before most of you were even born, before the days of digital printing, before the days everyone had digital printers, we used to have print bureaus. They were back in the days when there were a couple of companies that had digital printers and they did the printing for everybody else. So if you wanted some printing done, you'd send the image to another company who would do the printing and send it to you overnight. There was a company doing print bureau work down in Dunedin and they rang me up and said, Michael, I've got a problem. I can't get my printer to print properly. It's giving me all these really nasty non-wets. And a non-wet is where the ink doesn't stick. It just pulls away and leaves you a spot, generally a white or a light colored spot where the ink is just not settled in. It's just pulled away from it. Usually that's contamination. So I asked him all the obvious questions about contamination, and this guy, knowing a lot about digital printing, was able to confirm that, as far as he was concerned, it wasn't contamination at his end. So he said, okay, I'll send you another roll. So we sent him another roll out of another batch. It went down overnight and he got it the next day. He rang me the next morning. He said, Michael, it's still the same. It's still not printing properly. So we sort of went through everything and I said, well, it's the middle of winter. What's it like down there? He said, oh God, it's been nasty. It was sub-zero overnight. It was freezing. And I said, well, when did the roll arrive? And he said, oh, the courier dropped it off this morning. And so I said, what happened? He said, oh, we just grabbed it and chucked it straight to the printer. So I said, where's the roll you were having problems with yesterday? And he said, oh, it's standing here beside the printer. And I said, swap it over and print the roll you're having problems with yesterday and give me a call back. He phoned me back about 10 minutes later and said, oh my God, you're a miracle worker. You've solved the problem. And he was saying it works beautifully. Well, I didn't actually solve it. What he'd had was the roll that he had problems with yesterday had just come in and it wasn't acclimatized. So the roll he was using was freezing cold. The roll he had problems with that morning had come in from the courier. It had probably spent all night on the courier floor freezing cold. So he'd put a roll sub-zero into the printer. And he said it actually even looked like snowflakes. Yeah, it probably was. It probably was frozen moisture on the roll that was causing him the problems. So the roll that it had sitting beside the printer had been sitting there for 24 hours, had acclimatized beautifully and printed just wonderfully. So that's why we say try and keep your rolls next to your printer. Even if you're not storing all of them, just keep one roll, the next roll that you're due to open, keep that next to the printer. It will make your life so much easier. Now, the next lovely anecdote I've got, dispose of the half a meter before loading to avoid contamination. Nobody ever does, but that's essentially what we're saying should happen. What we're saying is when you load the media, pull half a meter through and throw it away. No one ever does it. I don't do that either. But out in West Auckland many years ago, we had a printer out there back in the early days of digital printing. They had a problem with, once again, non-wets. They were getting problems where the ink wasn't sticking. And they said, oh, it only happens on 3M film. It doesn't happen when we use anybody else's film. Oh yeah, here we go. You can see this one coming. So we went out there with the distributor and we asked all the right questions. We looked it up and it wasn't ideal. These were the days when people really didn't understand and their printer was out in the factory with everything else. It wasn't in a controlled environment. It wasn't in a room of its own. It was just out in the middle of the factory. And so we asked all the questions and he said, it only tends to happen over the first half meter or so of the film. It doesn't happen beyond that. So it doesn't happen on, as I get into the film. And so we figured out that it was happening in the morning. So when he first came in the morning, he was getting contamination. So the more we looked at it, the more we figured out it was only happening on the first half meter of film first thing in the morning. So I said, humour me, who are your neighbours? And he said, what do you mean? I said, just can you tell me who you've got here? He said, oh, there's a bakery next door on that side, and then oh, there's a car groomer on the other side. Nah, car groomer. It never happened in the winter. It only happened in the summer. So now we're sort of getting somewhere. What it was contamination from silicon spray when the car groomer got outside and started spraying silicon to shine up the car tires. The silicon got into the air, blew into his factory while he had the roller door open, settled on the media in the printer overnight, and caused him the problems the next morning. Sound incredible? It's what it was. Contamination from the environment, from the neighbor next door. So we officially say dispose of the first half meter to avoid contamination. We know it doesn't happen, but just be aware if you're getting problems like that, that's possibly what's going on. It's contamination in your printer. Mind you, as the years have gone on, a lot of people are looking after their printers better and they're putting them in better environments, so this isn't as much an issue as it used to be. And that's what I say, acclimatization, allow the media to reach the same temperature as the print room. And that was the problem we were having with that guy in Dunedin. Allow at least 12 hours for it to come to the same temperature as the print room. Now the print media itself, the most common print media is going to be PVC or vinyl, either as a self-adhesive or as a banner. We generally have two types of vinyls. I know most of you are quite familiar with this, so I'll rush through it quite quickly. We've got cast and we've got calendered. Cast lasts, it's the long-term film, it's the one that's going to last a long time. Calendered has a calendared or dated life, it's not going to last as long. So the different manufacturing processes, and I'm not going to go into it, different manufacturing processes will give you two types of vinyls that will last in different ways. We put lots of ingredients into cast vinyls to make them last very well. So cast vinyls are going to be the long-term vinyls, and they're going to last a long time. Calendered, not so much. So if we add in resins, plasticizers, solvents, flame retardants, we make a liquid and we smear it out onto the surface, and we smear it out thin with a thing called a doctor blade. We make a very thin film. That very thin film, we bake it over 200 degrees. Now, this one is worth looking at here because we get asked a lot of questions around environmental sustainability. We do use solvents when we make these cast films, but what we do is in those ovens, we evaporate off those solvents. So by the time you get them, there is virtually no solvent left in them. And most of our films don't even contain solvent in the adhesives now either. Those solvents that we evaporate off, we don't let it go to waste. We scrub the solvents out of the outflow from the ovens. We collect it, we purify it, and we put it back in. So environmentally, we have been doing our best for many, many years. We get a lot of people saying, what do we do with the liners? Can we recycle the liners? Unfortunately, in New Zealand, there is nowhere that can take a silicon-based liner. So unfortunately, we can't recycle the liners because there's no one in New Zealand that can take silicon. And if we didn't put silicon into the liner, you'd never get it off the vinyl. So we do our best to recycle and reuse as much as we can. That's how we make cast films. We make a liquid and we smear it out thin like buttering bread and make the film that way. Calendered vinyl is calendered or rolled, similar ingredients to cast vinyl, but it's stretched and rolled. We don't put in nearly as much of the stabilizers, and you can see from this end of the picture, we squeeze it out like a dough and we roll it, we heat it and we roll it and we make it very thin, and then we chill it down and set it. So you can see that there is stress in that film. Not going to go into the details, but cast vinyls are thin. They are essentially low shrinkage, long-term outdoor durability, and the sort of thing we would use for vehicle wrapping. Calenders are much thicker. They can have significant shrinkage. They're only going to be short to medium term, and I wouldn't try wrapping a vehicle with it. Not going to go into any details. We certainly don't have time, but if you go to 3mgraphics.co.nz and the drop-down box there where it says resources, you'll find technical bulletins and just about everything you ever wanted to know about the products you'll find in there. Going on to the printer room environment. Printers are designed to operate in very specific environments. Essentially, if you like to be in that environment, your printer would like to be in that environment as well. Inconsistent environments will give you inconsistent prints. So really what we've got there is printers like to be at around 20 degrees and around 50 or 60% humidity. That's the sort of thing that humans like as well. What we found is that if you take your printer outside that environment, you can get problems. I know that there are large printing companies in Auckland that simply can't control their environment, so they're out in open factories. They may have a dozen or more printers, and they know that they'll get inconsistencies from summer to winter. So something they'll print in the winter, they won't be able to use the same settings in the summer. So they'll need different settings depending on the environment or the temperature and the humidity that they're running in. And I've certainly seen it, ones where they'll get a job in the winter and then they'll get 6 months later, they'll be asked to reproduce the job and they'll struggle because the environment has changed for them. One of the best examples of that was a company up in the islands. They bought a second-hand printer off Trade Me in New Zealand, and they got it shipped up to the islands. And because they didn't know any better, because it was a second-hand printer off Trade Me, they put it into a garage in the islands, and it was 30-something degrees in there during the day and very high humidity. They never actually got the printer working because by the time they got it out and set up, all of the heads were blocked because of the high temperatures and the high humidity. They needed to then get a technician out from Auckland to service it, and the cost of the technician and the cost of 4 new heads, which is what it took, was more than what they paid for the actual printer. So it really wasn't a good option for them, but once again, unfortunately, it was a matter of ignorance. They simply didn't know because they didn't have all the details because it was a second-hand printer. They didn't know that their printer needed to operate in a very specific environment. After the service technician replaced all the heads, They put it into an air-conditioned room, and as far as I'm aware, that printer is still printing today, 6 or 7 years later. It'll be well past its use-by date now, but it's probably still printing because it's in its correct environment. And once again, check your user manual for requirements. Every printer is going to be slightly different. I do also know that a number of UV printers, there will be requirements for air conditioning for the room and air replenishment. So for some of those big printers, you're not just looking at power for the room or air conditioning, you actually need a high volume fan to change the air within the room. And a lot of that is because UV printers can create quite a lot of ozone, and ozone can really smell bad and can be quite harmful. So it's quite important to check the user manual for exactly what you need for your printer. I can't tell you exactly what your printer needs, but check the user manual will make a big difference to how you control your printer environment. The next requirement is for air conditioning. You do need to air condition the room that your printer is in. It needs to be on a flat, level floor. It needs to be on a hard floor. I can't say hands up everyone that's got their printer on carpet, but if you have, you're naughty people, get rid of the carpet as quickly as you can. I've had some people say, oh yeah, but doesn't the carpet keep the dust down? No, it actually makes it worse. It traps the dust. So as you walk past, you will be kicking dust up out of the carpet. How many of you have ever peeled up a carpet at home that's been down there for many, many years, and you pull up the underlay and it looks as though someone's had a fine time at the beach? There's a truckload of dust or sand under the carpet. That's basically dust and dirt that's been trapped by the carpet and made it right through. Essentially, that's what you don't want under your printer. Anytime you get that under your printer, you're going to get it kicked up and it will contaminate the print surface from time to time. Not immediately, but commonly it will contaminate that surface. So you do not want carpet. Clean, dry, dust-free is what you're after. So you want a floor that can be cleaned and dusted and vacuumed and even mopped. Now, I say no direct sunlight, and you can see the picture of that printer. It looks as though it's sitting right in front of a window. What you can't really see is that there's a pillar outside the windows here, and there is an overhang. The upper story of this building overhangs those lower windows by a good 2, maybe 3 meters. So essentially, that room where the printer is never going to get direct sunlight. You definitely do not want to have your printer anywhere where it can get direct sunlight. It will cause major problems with your printing. There is an incredible amount of power in sunlight. Sunlight will majorly affect how your printer works, so keep it out of the sun. Do not leave your printer in direct sunlight. So the next printer operation one is how you load your media. These pictures come from a Roland, but it doesn't really matter which printer you've got. They're all going to be similar in some sort of ways. For example, this Roland has core plugs. So you can see the plug here that goes into the end of the roll and holds the roll up off these bottom rollers. Without the core plug, the roll actually sits on those rollers and it will increase the friction. Just go back one there. It will increase the friction on those rollers. So it will make it very, very hard to pull the roll through if you don't have them on there. And the other thing it will do is it will transfer any dust off those rollers onto the media. Now, if you've got an HP, HPs have got loading mechanisms, and they've got a mandrel that goes through the middle. So you put a bar through the roll and you load it in and it loads the media itself. What a fabulous idea. I wish all of them would do that. My old Roland doesn't do that. I've got to load the media myself. But essentially, same idea. You've still got to keep that roll supported so that that media is not contaminated. You want to make sure that the roll is not sitting on a surface or is not picking up dust from somewhere. A number of the more modern printers will have covers over the back so that you don't end up with the contamination that print shop got with the silicon from their neighbor. So those sort of things, as time goes on, we are trying to get around a lot of those issues, and a lot of those issues are being solved by the company that has been making printers. So load the media so the print surface is not contaminated. You can see my colleague Chris from Australia, he took a number of these photographs for me. We gathered together on this presentation, and so you'll see Chris in a couple of places in here. Ensure the media is loaded straight to avoid skewing and possible head crashes. So essentially what Chris is doing is when he's loading the media there, he's pulling it in the middle. So he's pulling it through and giving it a bit of a wiggle as it comes through to make sure it's loaded straight. The HP guys, you've got it easy, it loads it for you and will avoid that skewing. So you've just got to make sure that the printer comes through properly when you pull it like that. Now, a number of people will pull the vinyl right down around the dancer bar, which you can see at the bottom here, and then onto the core at the bottom. Chris has got a bit of tape on there and he's going to tape it around onto this core underneath. I recommend only putting one piece of tape on there. A number of people use 2 or 3. The trouble with 2 is that you can end up with it skewed. So even if you're a millimeter or 2 out when you put those 2 pieces of tape on, you'll find that the roll winds itself sideways and will telescope as it winds up. To avoid that, just use 1 and it will tend to self-center it. So all you've got to do is, as the printer starts to print, make sure that the roll, as it winds around the mandrel at the bottom, make sure that the edges of the roll are coming around there cleanly and it will wind up beautifully. You can do it with 1 piece of tape. I tend to use 1 piece of tape purely because I know that I'm going to get a nice tight roll. Now, there are 3 calibrations for almost all printers. What it calls it depends on your printer. Where you find those calibrations, they will be somewhere in the printer settings. I can't tell you what they're called or where you can find it because every printer is going to be a bit different. But the 3 calibrations are a nozzle check, a feed calibration, and a bi-directional calibration. And we're going to discuss each of those one by one. First of all, the nozzle check. The nozzle check is a test that all the print heads are firing correctly. Essentially what it does is it just shoots a little bit of ink out of all of the nozzles just to see that they're actually working. What it will show you is it will show you 2 things. It will show you whether you've got a blocked nozzle. A blocked nozzle is where there is a nozzle in that ink head where the ink is not coming through at all. And it will leave you a gap in the print. So you can see there is a stripe missing completely. Or it will show you if you've got a deflecting nozzle. A deflecting nozzle is where there's a little bit of crud just right in the nozzle. So you can see there's a little bit of crud just on the edge of the nozzle. So when the ink comes through, it gets pushed off to one side. So the ink will shoot out sideways out of the nozzle. And you can see here in the print, we've got a deflecting nozzle. You can also see deflecting nozzles where if you look at the alignment of the print, if you get a line that isn't in line with the others, so the alignment left to right is out, that also denotes the deflecting nozzle where the ink is being pushed out to the left or the right rather than up or down. So you can get different scenarios. All of those, if it's simple like that image that you see in front of you, that's a test print I took off my printer. A number of those block nozzles or deflecting nozzles can often be sorted with a clean. Now, what sort of clean you do? Most printers will have just a quick clean through to a really deep clean. The deeper the clean, the more ink that it will use, because essentially what it does is that it will push ink through the heads to try and clean them. Some of the more modern printers, there are printers out there now that do actually contain an entire cartridge of cleaner. So there are some printers with a cleaner cartridge in them, and when you tell it to clean the heads, it will blow cleaner through the heads, and then it will reload the heads with ink. So it will save you a little bit of ink, and it will use cleaner to clean the heads. Modern printers, it's amazing how much they change things. They're printers that are probably just in the last sort of 6 to 12 months, you've started to see printers with cleaners in them. Now, yellow can be a very difficult print to read. If you've got a blue or a UV lamp, and you can pick them up from JCar if you want one, they're quite cheap. They're only about $5 or $10. You can get yourself a little UV lamp, and if you turn on the UV lamp, it will shine through and show up the blue quite dark. And you can see the 2 prints here. The yellow can be very hard to read, but it's much, much easier to read if you turn on a little blue light or a UV light. It will show up that yellow ink quite clearly. It can be quite hard to read these test prints. They are only literally probably 50 or 60 millimeters in size. They can be quite small. The next one is the media feed calibration. And unfortunately, it's not a very good image. You may struggle to see this here on this image, but essentially the media feed calibration is calibrating the amount that the media pushes forward out of the printer between print passes. This will be the major cause of print banding. So if you get an image that's got dark bands or light bands in it, that's probably a media feed calibration issue. So if your printer pushes slightly too much media out between the passes, it will leave a gap between the band of ink that it lays down. So it will leave you a light spot. Now, if you've got your media feed calibration set the other way and it's set too short, you'll find that you end up with a dark band. And the dark band is where the layers of ink have overlaid each other. So banding, whether it's light banding or dark banding, this image, it's hard to tell, but it is dark banding. There are dark banded images through that image. I wish I had a better picture of that, but I don't. Those can usually be sorted with a media feed calibration. What your printer calls it and where to find it, I don't know. Once again, from my Roland, it looks like this. The one on the left, it will print a calibration and it will print you a set of overlays where it will go from a gap through being correct through to an overlap, and it will have a little arrow under where the printer is set. And so if the printer is set here, then it's correctly feeding. If the printer mark shows you it's a gap or an overlap, then you need to tell the printer that it's incorrectly set and change the setting. Once again, depends on your printer. I can't tell you what it's called or where to find it or how to print it, but essentially there will be a media feed calibration somewhere in your settings. Check regularly. I would do a nozzle check every day, and I would probably do a media feed calibration every couple of days or maybe once a week, just to make sure that it's set. If you see any issues, do it straight away. Bi-directional calibration. Now this allows for differences in ink drop release when you're printing in two directions.
Sorry, Michael, can I just jump in quickly? We just got a question from Nathan. How often should you calibrate your machines?
I would look at doing a nozzle check daily. I would look at do a media feed calibration every few days or possibly once a week. It really depends how much you use your printer. If your printer's printing flat out all the time, I know people that do these checks every day. Every morning they'll do these checks before they start printing. And that's fine, got no problem with that. It really depends how much you use them. If you're printing intermittently and not printing so much, it may not be such a big deal, but you'll find that the less you print, the more your nozzles will get blocked. So you may need to check before you print every time. Depends very much on how much you use your printer. But I would say between daily and once a week, depending on how much you use them.
Right. Okay. So no hard and fast rule, but
no,
yeah.
Because it's going to depend very much on how much use the printer gets. And strangely enough, if you don't use your printer often, you will need to do at least the nozzle check when you start up, because if you've gone away for summer holidays and you've come back 2 weeks later, I could just about guarantee your printer's not going to print very well until you've given it a damn good clean.
Great. Okay. Thank you.
Bi-directional calibration. This essentially is your World War II bomber, gunner, aimer, where what you've got is the print head's moving and it needs to lay down a drop of ink to hit on the media beneath it. And it's going to hit in a specific spot. So it'll drop the ink drop. I can get the media. If it drops that ink drop from here, there will be a finite travel time before it lands there on the media. Now, pretty much every single printer I know prints bidirectional. Essentially what that means is that the printer prints in one direction and then the head comes back and it prints again going back in the other direction. So it's printing in both directions. So that's bidirectional printing. The reason people have set bidirectional printing is because it doubles the speed of the print. You print unidirectional, You will end up with a better looking print, but you'll end up with half the print speed. So you will halve the amount of time, sorry, you'll double the amount of time it takes to print, but you will increase the quality of the print. Most people print in bidirectional because it's much, much quicker. However, bidirectional comes at a cost. Bidirectional means you need to calibrate where the ink drops land on the media. And you can see here, if you're printing bidirectional, I can find my pointer's gone there. So my print head on coming in this direction needs to drop the ink there to land essentially in the same spot. You need to calibrate where those ink drops leave the print head. And that's the bidirectional calibration. So it allows for ink drop release when printing in two directions. Now that bidirectional calibration, I don't have a picture of it unfortunately, but the bidirectional calibration, usually you'll end up with two lines that are misaligned, and you want to find the spot where those two lines line up. And that's essentially where your printer is printing correctly in bidirectional calibration. Once again, I probably wouldn't look at bidirectional more frequently than once a week to once a month. It's not as critical as a nozzle check or a feed calibration. You've got another question there, Steve?
Yeah, sorry, mate. Long time listener, first time caller. We've got one from Shane. Is it bad to only use unidirection all the time?
No, not at all. A lot of people do. The only drama with unidirectional is that it's going to double the amount of time it takes to print. If you've got time to run it in unidirectional, you'll get a better looking print. It will give you a better image because you don't have the issues with bidirectional calibration. You don't end up with a slight misalignment because you're printing in two directions. So if you print in two directions, you will get some misalignment. So printing unidirectional,
great.
Yeah, great, go for it. But most people won't because it's much, much slower.
Okay, and same amount of ink between bi and unidirectional?
Yep, just half the speed.
Great, okay. And a question just from before in regards to how often you would check the machines, calibrate your machines, any difference with the latex?
Latex printers will have their own calibrations as well. Latex heads won't last nearly as long as a solvent head, but latex inks are much cheaper. Latex heads are much cheaper. It's a few $100s as opposed to some thousands of dollars. I would, once again, I would be checking those regularly because those latex heads are more prone to blocking and won't last as long. But once again, check your printer manual. Your printer manual will tell you what it needs to do. If in doubt, ask your service technician. More often than not, the service technicians don't want to do the boring stuff. They only want to do the fun and unusual stuff. They're more than happy for you to do a lot of these things yourself. Ask them and they can be a good source of information. I'm not that resource. I'm not a printer technician.
Okay, great. Thanks, Michael. Awesome question, guys. Keep them coming.
Yep, no problems at all with these questions. Okay, some other settings that you've got. You've got head height. Some printers will have a variable head height from almost nothing to something huge. Other printers will have a lever which is either high or low. Doesn't matter to me which you've got. Essentially what we say with vinyls is keep them as low as you can because you will get more accurate dot placement, and obviously any of those calibrations are going to be affected by the head height. So particularly the bidirectional calibration will be badly affected by head height. So the further up the head is, the more critical the bidirectional calibration becomes. So usually what I say is get it as low as you can, but you don't want the head to hit the media. And we'll talk more about head strikes later. So keep the heads down low. Heaters, critical for good print quality. So heaters, some printers will have multiple heaters. Some printers may not have heaters at all. UV printers don't tend to have heaters, but their UV printers run really hot because of the UV lamps. I've seen some solvent printers that have got 3 heaters. They've got a preheater, so they'll heat the vinyl coming into the printer. They've got what's referred to as a platen heater. The platen is that layer underneath the print heads with all the little holes in it. That's where the vacuum gets pulled. So when you turn the printer on, it sucks air through there to suck the media down onto there. So that's heated as well. So that's called the platen heater. Most printers most solvent printers well, all solvent printers will have a platen heater, and a lot of solvent printers will have a post heater. So they've got a heater on the out feed because they've got to get as much drying into that solvent ink as they can. Latex printers have got a number of different heat zones in there, so you won't be able to get anywhere close to that printer until it's taken it right past all of those heaters. How hot those heaters are, I get a lot of people saying to me, how hot should I run my printer? I have no idea. And a lot of people say, you're the printer expert, why don't you know? Well, actually, I'm not the printer expert, I'm the media expert, but I've had enough experience with printers to tell you that it depends on your printer and your environment. Even if you've both, you and another friend have got an identical printer, same make, same model, you may be running them at different temperatures because you'll have a different working environment. So, how hot are you having those heaters? Depends on your printer. The next one, print dryers. There are some printers that have got dryers, like they've got fans that will blow air over the media just before it rolls it up. If you've got print dryers, use the print dryer. The more drying you can get in your print, the better. That last one, platen vacuum. I just briefly spoke about the platen before. That's the bit that runs directly under the print heads. With the little holes in it, it sucks a vacuum and it holds the media down flat. So it means that the printer can print onto a flat surface. Most printers will have a vacuum in there of some sort. Even if you've got a belt that runs right through there and you can't see the platen, there will be a vacuum underneath that sucks that media down flat through the belt. So there will be a vacuum setting in there. Usually what I say with the vacuum is leave it on automatic or turn it on and don't change the settings on it. I've had people mucking around with the platen vacuum and it can cause all sorts of media feed problems. If you turn the vacuum up too high, you can get problems with the media feeding through correctly. I've seen people change the vacuum because they were printing a banner or a mesh and they were, the banner was much heavier or the mesh sucked too much air through, so they've changed that to suit. Yes, if you do change that vacuum, you do want to change it back because I would essentially say leave that on automatic. It's one more setting that you won't have to muck around with. Now, just can you let me know, can you actually hear this video that's playing? You just let me know, Steve, can you hear this?
No, I can't hear that.
That's fine. Right, I will carry on. That video that I was attempting to run there, my colleague Chris in Australia, it was a brief video that Chris has got called, it's one of Cookie's tips, and Cookie does a nice discussion on print curing. I can discuss everything that was in that video, and that's what we'll do now anyway. Okay, print curing, it's the process of allowing the ink to fully dry and harden on the media. It's critical for solvent printers because you do need to allow that print to cure after it comes off the printer. Now, UV and latex prints should fully cure on the printer. It doesn't mean to say they will. But if you've got your UV printer or your latex printer correctly set up with the correct temperatures and the correct number of passes, and you've got everything set correctly, it will be fully cured as it comes out of the printer. It is possible to run UV and latex printers in an incorrect mode that will allow a semi-cured ink to come off the printer. That is not what we're talking about here with print curing. That's a different proposition. What we're talking about with, if you get a UV print that comes off the printer that feels slightly sticky, get it out in the sun or put it back through again and try and get some more curing into that somehow, or turn up the lamp current or the lamp curing, because if your UV print comes out sticky, it's certainly not fully dry. I would try and get it out into the sun, but probably you'll be looking at reprinting it. Now, a latex print, what you can get with latex printers is you can get a print that appears to be cured straight out of the printer. You'll print it and think, hey, wow, this looks fabulous. You'll put it on a table and about 10 minutes later, it gets tacky again. Essentially what's happened is you've cured the surface and there's still some moisture inside that's coming back up to the surface. Unfortunately, sorry guys, that's game over. Throw it away, it's never going to cure properly. I get a lot of people saying to me, can't I just put it in the sun, or can't I hang it up to dry? No, unfortunately, that latex print will never correctly cure if it's not cured properly on the printer. So if you've got a latex print that's got a lot of dark colors in it, and you've really ladled in the colors and you've got a really dark color, and it's coming up sticky 5 or 10 minutes after you've printed it, sorry, that's a printer problem that you're going to need to solve on the printer. You're going to need to slow it down, increase the temperature, decrease the amount of ink laydown, but you're going to have to find a way of curing that on the printer. Those two problems with UV and latex are different to what we're going to talk about with solvent print curing. Solvent print curing is retained solvent that affects the behavior of the film going forward. You'll get poor film adhesion, you'll get edge lifting and curling, you'll get excessive film stretch, you'll get high initial tack, you'll get an easily scratched image, and you'll lose the air release function. So essentially what you're going to get is you're going to get a graphic that, and I'm sure you've all had this in the past at some stage, it's come straight off the printer, you're told to apply it, and oh my God, it's like chewing gum. Bum. It's horrible. You try and peel it off the liner, it peels up on you, it stretches, it's hard to use, it's hard work. Now, if you get a print straight off the printer, it's quite common for people to, oh yeah, I'll just fix it, I'll just laminate it and that will be okay. No, all you've done is you've trapped the solvent in that film and you've delayed its curing. So something that may have taken 24 or 48 hours to cure is now taking 4, 5, 6 or more days to cure. That laminate will effectively block the curing and slow it down. You can see from this image that this is an Australian image from out in the snowy mountains where this graphic was solvent printed and then applied straight away, and you can see how it's peeled up and curled around the edges. It would have been a nightmare for the people to apply. Usually that's what you'll see if you've got an undercured print. Got something for me, Steve?
Yeah, is it necessary to change the heat setting when using different types of media? So for example, printing on vinyl versus poster paper, or should the heat setting remain the same?
No, you're going to have to change the heat setting. And unfortunately, I can't tell you what the heat setting is going to be. The heat setting is going to be very dependent on the media that you're putting through. Now, you'll probably find some great settings that work on vinyl, and you'll find that you turn those down if you're printing on paper, or you'll turn them up if you're printing on banner. And that's purely because of the weight of the media or the amount of ink ingress into the media. It's going to depend very much on what you put through it. And you may actually find differences between cast and calendered vinyls. Calendered being thicker, you may find that it may need a higher heat setting. But once again, I can't tell you what those settings are going to be. It's going to depend on your printer. But yes, there will definitely be heat or temperature setting differences between medias.
Okay, and Mike had a question just around the curing time, the ideal conditions on an eco-solvent. Yep. So is there anything around that? So he said, yes. Is it like 20 degrees?
I was just going to get to that. It's a good question. I can't tell you how long your prints are going to need to hang to cure or what temperature, but you will find that they will cure faster in warmer environments, and they will cure faster if they're hung vertically. If you leave them rolled up, they're not going to cure very well at all. So you can see here these two pictures. The one on the left is Chris in Australia hung them over his pin rack, and my lab, I've hung them from a thing that looks like a washing line. So if you hang those solvent prints, essentially the solvent is heavier than air and it wants to run out the bottom. So if you hang them up, they will dry more quickly. If you can get airflow over them, they will dry more quickly. If you can increase the temperature, they will dry more quickly. Now, how quickly do they dry? It depends on your printer. I get a lot of people saying, how quickly, how soon can I use them? What I would generally say is, I would say a minimum of 24 hours. Some printers may need 48. I know some of the older Mamakis running the harder solvent inks will need a bit longer, but they will create a really durable print. A great print, but it just takes a bit longer to cure. Most Rollins, like my old VP 540, I would leave that probably 24 hours hanging up, but I'm in a fairly well-controlled environment. You've just got to be very careful. And those of you that have got latex and UV printers, a lot of this is irrelevant because you're cured off the print. Now, a lot of people will say, well, I just got it, I don't have the space, I've got to leave them rolled up. If you're leaving them rolled up, you want to make sure that there is space between them to allow it to cure. You've got two faces touching, they're not going to cure very well. You want to keep them separate. You also want to keep them off the floor because the solvent's heavier than air, it's going to drop down. So if you've left your print sitting on the floor, you're going to get a buildup of solvent on the bottom edge. So what we recommend is put it on some sort of rack, like a, nothing wrong with nipping down to your local hardware store or something like that, and getting a cake stand, the sort of thing that you would, that you'd take a cake out of the oven and you'd let it cool on a cake stand. Nothing wrong with that. You can see the one there that looks like something that looks like a rack out of a freezer or something. That's fine, that works well. I've also seen guys put fans into them. So they use something like a little computer fan in the bottom just to suck the air out the bottom. Make sure that the fan is sucking down and not pushing up. If you're trying to push air up into it, it's not going to cure very well because the solvent being heavier than air is going to want to drop down. So the curing time will depend on the temperature, how you hang it or loosely roll it, how much air you get across it, the amount of ink, the type of ink, and the image density. So images with lots and lots of dark colors are going to take longer to dry than light colors. And ultimately, it's going to be up to you to work out your curing time. Smell it. The scratch test. So run your fingernail over it. If your fingernail grabs and chatters across the surface, then it's still wet. Stretch it. If it feels stretchy, then you know that's probably not fully cured. So ultimately, you guys are going to be the judge as to whether your print is correctly cured. What I'm going to do is I'm going to hold it there with 15.
Sorry, one last one.
Yep.
Anything with a liquid laminate? Is there any extra cure times between print and laminate?
We don't recommend liquid laminates. And the reason we don't recommend liquid laminates is that you will get a variable thickness. So there will be parts of that liquid laminate where you've got a nice thick layer and it will take longer to cure. There are parts where you probably didn't get as much and it will cure more quickly. So we don't recommend them. We know people use them, either sprayed on or rolled on with a roller. There are actually liquid laminators out there, ones that will lay on a fairly even layer. Once again, it's going to be totally up to checking that, checking the situation. Now that's where I want to leave it because that is a complete change of gear into RIP and media and everything. So that's probably a good place to leave it. So we've got 15 minutes for questions. If anyone's got any questions, feel free to ask, and we'll carry on from RIP tomorrow at 10 a.m.
Okay, great. Thanks, Michael. So yeah, if anyone has any questions, feel free to fire them into that comment section now. And while I've got you, so I'll just cover off how it will work tomorrow. So we will send everyone that's here now an email with a link through to sign up for tomorrow morning's part 2. So whether you've signed up already or not, can you please just follow this and sign up if you wish to carry on and learn about part 2. And then you also get a reminder about an hour out before tomorrow's session as well. So Nathan's asked, can they get access to the sliders of this presentation?
Yep. After I finish tomorrow, you will get a completion certificate, and I will also send out to everyone a PDF of this presentation. Because if I was doing this in real life, you'd have a hard copy anyway, so I have no problems with giving people a copy of the presentation. We'll send that out to you after the session tomorrow.
Cool. Do you recommend using third-party inks? I'm
No.
surprised it took that long, yeah.
I'm surprised we didn't get this one earlier. No, under no circumstances use third-party ink. And please hear this, I'm saying this loud deliberately. For God's sake, hear me. It's false economy. It does not save you money. In fact, it will cost you money in the long run. If you use a third-party ink, you're voiding any warranty. Any warranty 3M gave you and any warranty the printer manufacturer gave you are gone. You have no warranty if you use a third-party ink. The reason for that is that we have no experience with that ink, with our media and that printer. There are too many variables. What we find with third-party ink is that you'll get it in your printer and this batch will work perfectly. The next batch will be too thin and it will dribble out of the heads, and the batch after that will be too thick and it will block the heads. Those are the sort of scenarios that you'll commonly get with third-party inks. Usually there are very poor quality standards on those inks. Not all of them. Some of them are very good. But once again, we have not tested them and we do not warrant them. So that's what I'm saying. Please hear me. Do not use third-party ink. It's false economy.
Right, he's pretty passionate about that part, folks.
I am.
Yeah,
I am for a reason. We offer warranties on what we do, and you've basically just wiped any warranty that you may have.
Yeah, absolutely. Is liquid laminate okay for banner material?
Yeah, sure. I don't have a problem with liquid laminates. We just don't recommend them because you don't end up with an even layer, and you will end up with, over time, you will end up with a variable result. So if you've got a large banner that's out there for a long time, you may get a spot on the banner that fails prematurely because it didn't have as much of the liquid laminate as other parts of the banner.
Okay. Galaxy S10 wishes to know, will the weight of a different media affect the media feed settings like PVC
yes.
banner? But yep, okay, so it definitely makes a difference.
It definitely makes a difference. So if you've gone from a very lightweight material to a very heavyweight material, you will need to check those feed settings. You'll find that the media feed calibration, when it's trying to haul through a big heavy banner, will give you feed problems, and you'll end up with having to alter that media feed calibration. You'll find that it'll end up too short and you'll end up with black banding or the dark banding. So it's quite common to get dark banding when you put banner in if you didn't check that media feed.
Okay. Adams asked, will tomorrow's answer trouble with reading OPOS marks on silver IJ180?
Unfortunately, no. It's one of those things where we will talk about it briefly, but essentially, if you're using the silver, the IJ180 MC120, which is the silver material, as digital printers, you guys are having a hard time because it changes the white point. The white point is the color of the banner, the color of the media, and the silver is a very, very dark white point. Unfortunately, I can't change that. It is the color of the banner, of the media. Essentially, you're going to have to make alterations to your files to cope with that. It's something that needs to be done in pre-press. If you want to use silver, you may need to alter the file so it prints correctly. I can't do anything about it.
All right. Daryl's asked, do you recommend using a sole-use computer to run your RIP/printer?
Oh, yes.
Oh, yes. There you go, Daryl.
That's one for tomorrow, but you can see the slide that I've got up to, and I've left it up here on the screen. What I do recommend is get as fast a computer as you can with as much onboard memory as you can, because the RIP happens in the memory. If you can get the entire file into memory, it's going to be much, much quicker to RIP. Okay. I've got a printer that I managed to get, it's actually a server. So I'm actually using a server. It's not running as a server, it's running as a RIP machine. And that thing has got 48 gig of memory. So it's not 8 or 4, it's got 48 gig. So I can take a 48 gig file and RIP it in the memory. Essentially, that's going to make ripping a much, much quicker task because it's not having to read and write from the drive to do that. So yeah, we will talk about that more tomorrow, but believe me, the faster computer you can get with more memory is going to make ripping much, much faster.
Yeah, okay. Phil and Abigail have asked, are warranties voided if you use liquid laminate? I think I know the answer.
Essentially, yes. Yes, they are. Because We don't have a liquid laminate that we would recommend. So if you
Yeah.
use liquid over laminate, we're not going to warrant the construction. So yeah.
Will tomorrow cover any sort of warranty side of it?
Not
for printing and things like that, or is that not really? Okay.
Not specifically. If you want to know more about warranties, we will be having a session next week. The sales and specifier session will cover more about the products, and there's more about warranty in there. Warranty, yep. We used to spend a hell of a lot of our time talking about warranty, different situations, different scenarios, and it's now with all the different types of digital printers and different over laminates we can use, it's got so complicated, it's easier to ask. If you've got a particular set of circumstances, ask me and I'll tell you what the warranty is.
Yeah. Okay, great. And that goes for us too, guys. If you any questions or if you need some clarity, feel free to reach out to any of the team at Computer Letter. James has asked, he goes, we've had issues with our short-term media and ink on the latex not laying properly on the media, and brackets leaving it spotty. Is this a setting or is it unavoidable, sorry, in some medias?
Tomorrow we'll talk about troubleshooting, and there are some hints and tips I can give you specifically for shorter term media. You may also find that unfortunately some media is generally just not as good a quality, and it is inevitable that it won't print as well. I know that our short term medias, our IJ20 and one that we've got coming, an IJ16, do print remarkably well for a short-term media, but sometimes you will get media that just will not print well.
Okay,
but there are
great.
I've got some hints for it tomorrow.
Okay, cool. Any special tips on keeping dust contamination to a minimum, aside from vacuuming and mopping when you have a sealed, polished concrete floor?
There are, you can use a thing called a negative ion generator. Essentially what that will do is a negative ion generator, sounds like science fiction, but actually they do work. They produce an incredibly high voltage in the thousands and thousands of volts and produce negative ions around tiny little spikes. And what that will do is that will pull the dust out of the air around that machine. So if you leave it running at the other end of your print shop, away from the printer, it will suck some of that dust down around the negative ion generator. So it will help to keep the dust away from the printer by pulling it out of the air at the other end of the room. Don't put it right next to the printer because it will pull the dust down on the printer.
Okay. Adam's asked, any rough computer specs as a RIP computer, or any suggestions, or does 3M have any, ideal specs?
No, there are no real ideal specs except to say the faster the better.
Cool.
My printer is getting quite old now, but it still does a fantastically good job because it is server technology. But most modern computers, I would look at processors like i7s. I would look at large solid state drives because they're faster and they're more reliable. I would look at RAID arrays so that you've got redundancy, so that if you do end up with a machine crash, you don't lose all your information. These are sort of things you need to talk to IT experts about. I'm not the expert in IT, but I can tell you, simply go fast with a lot of memory, huge hard drives because you've got massive files, and back them up with RAID arrays.
Okay, great. Will we be covering printing on both sides of media, e.g. car service window stickers? Not
specifically, but the rules there are generally is you're going to have to try and get alignment. So alignment can be one of your biggest issues. Yes, you can print on both sides. Are they talking, so the question there is, are they talking a clear image that you want to print on both sides to get a depth of an image? Or are you printing on something where you're trying to put a white layer in between and you're trying to get a different image on both sides? Because that can be done as well.
Okay, Daryl, that might be a good question we could email through to us and we can pass it on to Michael or whatever works for you if we want to drill into a bit more specifics
essentially
around that.
What we're saying with that second one is there are printers out there. I've seen one of our customers in Australia has got a massive great Oki printer, which is 9 colors. And that 9 colors are CMYK, white, and then CMYK. So they can print, they can put a clear media in, and they can print an image in CMYK. They can lay down a layer of white, then they can lay another CMYK image on the other side. So when they put that on glass, they get one image on one side and one image through the glass on the other. Completely different images, separated by the layer of white through the middle.
Okay. And last question, Adam's asked, will tomorrow be based around one RIP software?
No, we're not specifically covering a RIP software. What we will be covering is generic to all the RIPs, but the generics, as I say, we can't get too specific into one type, because I can think off the top of my head at least of a dozen different RIP software, and everyone's going to have something different. So tomorrow we will be talking still generic RIP, but there are some things amongst that RIP that are common to all of them.